Okay, so use your calculator to find the first 5 terms of the sequence a sub n equals 10 times 1.5 to the n minus 1. Okay, so you could plug this in y equals, or if you do stat on the, or sorry, not stat. Where's my eraser? Pen. Eraser. Okay. Okay, it's not going to let me erase, so let's cross out. Okay, so if you go into mode on your calculator, okay, you'll notice, hold on, I had to get a calculator. So if you hit mode on your calculator, you'll notice that you have the choices of function, which it automatically defaults to, parametric, polar, which we're doing next, parametric, and something that says SEQ. So that is the one you want to go and highlight. If you go and highlight sequence, then go to y equals, oops, let's take my pen. So then go to y equals, and you'll notice that it kind of says n min equals 1, ... u slanted n. So you're going to write your equation in here. So you would write 10 to the 1.5 n minus 1. Now, you notice when it says n minus 1, there's a button on your calculator where you usually get your x variable. It says x comma t comma theta comma n. That's the one you push to get the n. This is function mode, parametric mode, polar mode, sequence mode. So when you press that button now, it will give you an n. Hold on, let me type it in. And then all you have to do is hit second and graph. And you'll go into basically your table, and you can get your next numbers, which are going to be 10, 15, 22.5, 33.75, and 50.625. There are my values for that. Example 9, and I told you to change this on your note sheet because what I had on here was what our old book did, and I forgot to change it. It says, write the first 5 terms of the geometric sequence, determine the common ratio, and write the nth term of the sequence as a function of n. So on a test, I'm not going to keep telling you this, so you might as well get used to what it says. If I say write the nth term of a sequence as a function of n, I basically mean write it in the explicit formula. So right now I'm giving you recursive, and anytime you write a recursive equation, you have to give me the first term. And when we're trying to read this, think of a sub n as your current term, the one that you're on, the one that you want, and a sub n minus 1 is your previous term. Okay? Or you plug in the numbers, you do plug and chug, a sub 2 minus 1, which means 1/3 of a sub 1. So you're doing 1/3 of your previous term. So if I'm doing 1/3 of my previous term, that means that's 81, 27, 9, 3, etc. Because we already have the, oh, actually we got to do one more. Let me erase that. 1. And it keeps going. So that is my sequence. Then if I want to write it as an arithmetic, my a sub n, as an explicit, my a sub n equals my first term times my ratio raised to the n minus 1 power. And again, you may not multiply the 81 and the 1/3 together. Okay, for some, there's going to be 2 different equations. It depends on whether you have a finite or you have an infinite sequence. An infinite, you'll notice that there's going to be an infinity above your summation, whereas a finite, there will be a specific number up there. There's 2 equations for sum of a finite, and yes, you need to memorize these. The first one, if you want to use this one, you only need the first term and the ratio. On this one, you need the first term, the ratio, and the last term. So depending on the situation of the problem, what they give you, you might use one or the other. On an infinite geometric sequence, you're doing sum to infinity. You only need the first term and the ratio. So same thing here, you need the first term and the ratio. Sometimes this is easier if you have, depending on your numbers that you have and just the type of problem that you have. So for the first one, I'm going from 1 to infinity. That's summation notation. So I need to use my infinite equation. So I need my first term and I need my ratio. Your first term you get by plugging in the 1 into your equation. Now be careful on this. The 4 is not necessarily going to be your first term. I know that your original equation, if you go back to it, was a sub 1 times r to the n minus 1. But keep in mind, that's only if I start with a 1 and this works out evenly. If I want to find the sum from 5 to infinity, plugging in 5 here is not going to make the first term in that grouping my first term. So that's why on all of these, you kind of have to keep that in mind, that a sub 1 is the first term in that group. So it really could be an a sub 5, it could be an a sub 6, it could be an a sub 7. So really you just have to plug in whatever number is here into that exponent. So if I plug that in, I'm going to get 4 times 0.6 to the 0. Anything to the 0 power is 1. 4 times 1 is 4. And my ratio is always the number that's at the base of your exponent. So my sum to infinity is going to be my first term over 1 minus 0.6, which is 4 over 0.4, which gives you a sum of 10. Now remember, when you're going to infinity, you're probably going towards an asymptote. And so as time goes by, the amount, the y value that you get from any particular, or the sequence value that you're going to get from any number, the term, are going to get smaller and smaller and smaller and smaller. And they're not going to add anything to this. And eventually they're going to go to what we call a limit. And the limits is the last thing that we're going to learn this year. Okay, next one, this one is from 1 to 10. Okay, so we're going to have to use the finite equations. And I'll do one of each equation. So on this one, let's use the second equation. So that would be S sub n equals a sub 1 minus a sub n r over 1 minus r. And I don't care which one you use, as long as you use one of the two. So my first term, I'm going to get by plugging in 1. So 16 times 2 to the 1 minus 1. So 16 times 2 to 0 is 16. My a sub n is, basically you're going to have to plug in 10. So a sub 10, because I'm looking for the sum of 10 terms. 1 to 10 is 10 numbers. So I'm looking for my last term. So think of a sub n as your last term. That is 16 times 2 to the 10 minus 1. That's 16 times 2 to the 9th, which is going to give us 8192. This is 8192. My ratio is 2. I'm going to put it all over 1 minus my ratio of 2. So, and when you're doing these on your calculator, my suggestion is use your alpha y equals button so that you can get fractions, especially if we have fractions within fractions. That gives us 16,368. Okay, 12. This time we're going to infinity, so we're going to go back to our s to infinity is a sub 1 over 1 minus r. Our first term I get by plugging in 1. 3 times 0.1 to the 1 minus 1 equals 3 to the 0.1 to the 0 equals 3 over 1 minus my ratio is the 0.1, so 3 over 0.9 ends up giving me 3 1/3, oops, or 10/3 for that. 15, okay, keep in mind if I'm going from 0 to 15, that's 16 terms. You may or you may not need that, but I'm going to go look at it. So, and this is why I wanted to do the first one. So, S sub n, we're going to use the first equation just so that you can see that being worked. So, another difference is, in this particular equation, you need your number of terms, whereas in the other one, you don't need your number of terms. So, my first term here, I'm going to get by plugging in 0, first term, into my equation. So 4/3 to the 0 power is 1. 2 times 1 is 2. And then that's 1 minus my ratio is 4/3. And again, this time I have 16 terms, so I'm raising this to the 16th power. So that's the only thing you have to be careful of this. And especially on this one, I would put it, use your alpha y equals, hold on, alpha y equals, to use fractions within fractions. And when you do that, you're going to get 592.65.